Now we're looking at example 5 from difficulty 3, and the expression that we're looking at is 3y to the fourth plus 21y squared plus 36. So now this is going to combine the two techniques that we've talked about in difficulty 1 and 2, and also some of the techniques that we've talked about so far in difficulty 3, noting that we have a leading coefficient of 3 here in front of this y to the fourth. Also, we notice that we have y squared here in the second term, which is half the power of the first term. So we're going to need to both factor out a 3 here from all the terms, if possible, in addition to substituting in something so that we have a normal quadratic here. So that means like we'd have an x squared as opposed to y to the fourth. So it doesn't, again, like the last example, it doesn't matter which order you do things. You can either substitute first, or you can factor out this 3 from everything in sight first. I like to do the factoring out by 3 first, so it becomes clear how we're going to do the substitution. So let's do that. Rewriting, I get 3y to the fourth plus 21y squared plus 36. I'm going to factor out this 3 from everything. So I have 3 times the quantity y to the fourth plus 7y squared plus 12. Okay. So now, I notice that I have this quantity y to the fourth plus 7y squared plus 12. I want something in the form x squared plus something x plus something else. So how do I get that? That I can do via substitution. So I say, let x, doesn't matter what you can choose, you can use smiley face, you can use a z, doesn't matter what letter. Let x equal y squared. Usually you're going to let it be the second term, whatever the variable expression is here on the second term. And then we have, this is going to be equal to 3, carrying along the 3, just so we stay consistent. And then every place I see a y squared, I'm going to replace it with an x. So I have a y squared here, I'll replace that with an x. But this is a y squared squared. So that becomes x squared plus 7x plus 12. Okay, so now we have a good substitution in hand. Now that I have this all factored out as such, I want to find two numbers that add to 7 that multiply to 12. So we're going to look at the factors of 12. So we have 3 and 4 are typically the ones that come to mind first. Do those add to 7? Turns out yes. So we picked good numbers from the get-go. So we have 3 here and a 4 here. That gives us 12. And when I add them, I get 7. So that's convenient. That allows me to factor this as follows. 3 times x plus 3 times quantity x plus, oops, so this should be 4. X plus 4. Now this is completely factored in terms of x. You might be tempted to stop here, especially with the substitution of x. However, remember our original expression was in terms of y. So we want to have y stuff here. How do we get it back? Well, we just refer to our substitution. So every place I see an x, I'm going to replace it back with y squared. So doing that gives me 3 times y squared plus 3 times, well, I'm replacing this x here with this y squared. So that gives me y squared plus 4. Now I have something completely in terms of y, and this is completely factored. I cannot factor these things further because there is no sum of squares formula that will allow me to do that, unless you want to use complex numbers. We don't here. So at this point, this is completely factored, and if you were to expand this and FOIL it, you would get back exactly the thing that we started with. So at this point, we are done with the 5th example from difficulty 3.